Hey there, we are now recording, and we are going to do Advent of Code Day 5. And I hope this one goes better than Day 3. Maybe it'll go well like Day 4. So, a maze of twisty trampolines all alike. An urgent interrupt arrives from the CPU. It's trapped in a maze of jump instructions. It would like assistance from programmers with any spare cycles to help find the exit. The message includes a list of the offsets for each jump. Jumps are relative. -1 moves to the previous instruction, and 2 skips the next one. Start at the first instruction in the list. The goal is to follow the jumps until one leads outside the list. In addition, these instructions are a little strange. After each jump, the offset of that instruction increases by 1. So if you come across an offset of 3, you would move 3 instructions forward, but change it to a 4 for the next time it is encountered. For example, considering the following list of jump offsets. Positive jumps forward move downward, negative jumps move upward. For legibility in this example, these offset values will all be written in one line, the current instruction marked in parentheses. Okay, so before we take any steps, we're at 0, jump with offset 0, that is, don't jump at all, then get incremented to 1, step forward because of the instruction we just modified. The first instruction is incremented again under 2, now we go to 3, increase it, go -3, increase that one, go 4, and then we're out of the maze. In this example, the exit is reached in 5 steps. How many steps does it take to reach the exit? Okay, so I think I understand this. So let's day 05 jumps.py. Okay, and as always, I am going to copy the link and put that in the doc string so that we know where this is. And what is this called? This is called how many steps to reach the exit. So let's say steps to exit, and we start with some offsets. Let's jump offsets. So jump offsets, it's a weird name, which is a list of int, and that's going to return an int. So that means that from typing, we need to import list. And we're going to destroy this list when we work on it, which I don't particularly like. So I'm going to make a copy of it. Jump offsets equals jump offsets : Okay, so that just makes a copy of the list, and that way, if we pass the list in, we're not actually destroying it as we go. And what we want to do is the current position equals 0. Okay, and so while the current position is bigger than 0 and it is less than the length of jump offsets, so we want to see how many, and we want to return number of steps. So let's say number of steps equals 0. Okay, so while the current is 0, and while, so basically these should tell me that I'm still on this list. And so then I want to do 2 things. I want to do offset equals jump offsets cur, and then I want to increment that, right? Or not increment what I got. So, here in this example, we get 0 as our offset. Now we want to increment the list at that. Jump offsets cur. We want to add 1 to it, so plus equals 1. And then we want to add that offset to the current, and current index. I'm just going to call it, no, I'll call it cur. It's a bad name, but I don't want to type it out. And then I want to do num steps plus equals 1. And so just to test this out, I'm going to print current, num steps, and jump offsets. So, before we were writing all these tests with asserts, but here I'm going to just print it out first. Test offsets equals, so in their example, it's 0, 3, 0, 1, 3. And we want to print, actually I don't need to, oh, yeah, actually let's do that. And then return num steps. So print steps to exit of test offsets. So I think that's pretty reasonable, and I call that day05 jump. So let's start up in IPython and say run day05 jumps.py. And if we look at their example, 0, start at 0, and then what did I print? This is just num step, so that's actually not that exciting. Current num steps. So it looks like I got the wrong answer. So let's figure out why that is. So I have 0, 3, 0, 1. Oh, well, part of it is that I set up the test case wrong. So let's try that again. And now I think I have the right answer. So I have 0, 3, 0, 1, 3. I don't go anywhere, and I go 1, 3, 0, 1, 3. Then I go to 1, and I've got 2, 3, 0, 1, minus 3. Then I go to 4, and I've got 2, 4, 0, 1, minus 3. Then I go to 2, 4, 0, 1, minus 2. And then I jump 4 steps forward, escaping the maze. So this looks right. And so now let me just turn that into a test. Let me get rid of this print statement. And I'm just going to assert steps to exit test offsets equals 5. And probably I should write more tests, but because I stepped through it, I feel pretty confident that it's doing what I think it's supposed to be doing. So let's get the puzzle input, and there's a lot of stuff. Okay, good. So let's save as, and call that day05 input.text. So if name is main with open day05, did I call it input? Yeah, I can see it down in the bottom, .text. Read as f. And then the offsets, I'm just going to read in each line. And let me just check this. What if I do int 34 new line? Does that work? Okay, yes, I don't need to do a strip. Offsets equals int line for line in f, and print steps to exit of offsets. Okay, so that is a lot of jumps. Huh. All right. It seems like a lot, but well, you know, a number of these are like in the -700, so that tells me that I'm going to have to go through them 1,000 times. Boy, this seems like a lot, but sum of offsets. Wow, that's a actually, you know, if those actually sum up to that, then still seems like a lot of steps. Well, let's try it. The worst we can do is get it wrong, right? And if I go here, okay, that's the right answer. It seemed big, but it looks right. So all that hand-wringing for nothing. So part 2. Now the jumps are even stranger. After each jump, if the offset was 3 or more, instead decrease it by 1. Otherwise, increase it by 1 as before. Okay, well that's not that strange. let's just, boy, and you know, in keeping with my bad naming for stuff, I'll call this steps to exit 2. And so all they said is that if offset is 3 or more, instead decrease it by 1. So if it's greater than or equal to 3, jump offsets cur minus equals 1. Otherwise, you know, as before, we increment it by 1. So that's the only change. Using this rule with the above example, the process now takes 10 steps. So again, let me print cur jump offsets, and this is in lieu of writing actually a good unit test. So print steps to exit 2 of, and what did I call that? Test offsets. And they're saying now it should take 10 steps with those offset values. So let's run it again. Took 10 steps, and 2, 3, 2, 2 minus 1. It said 2, 3, 2, and I didn't increment the last one, so that's fine. So I think that's right. Let me change this to an assert. Steps to exit test offsets equals 10. And now let's print steps to exit 2 of offsets. And now I can run it again. And I forgot to take out the print statement. So let me take out the print statement because I don't want to print, you know, hundreds of thousands of times. And run it again. And this has taken a good long time. Okay, well, that is a large number. 25,558,839. So I think we feel pretty good about this. So let's submit it. And that's the right answer. We're 1 gold star closer to debugging the printer. So still have an hour left until I can do problem 6, so I won't do that right now. But I will do that next time. So thank you for watching. I am glad this one went well.